This is the last question on the paper, and therefore it's not always the case, but it's probably going to be quite involved. Okay, let's have a look at it. We have a cylinder and we have a sphere, and it says they've got the same radius, r. Then we've got this gobbledygook here. Given that the total surface area of the cylinder divided by the surface area of the sphere equals 2, find the value of the volume of the cylinder divided by the volume of the sphere. Okay, let's have a think about this then. What they are saying here is that really what they're saying is that the scale factor, if you like, of the surface areas is 2. Okay, but let's just see what do we know about surface areas of cylinders and surface areas of spheres. Well, let's just look back at the formula sheet for a moment, if I can find it. Here we go. Now, okay, well, we've got a couple of things which are going to come in very handy here about the sphere. We've got the volume of the sphere, which it says is 4/3 pi r cubed, and we've got the surface area of the sphere, which is 4 pi r squared. Now, if we look down a bit, is there something about volumes of cylinders? And the answer is yes, here. Okay, down at the bottom here. So we've got the volume of the cylinder is pi r squared h, where h is the height, and the curved surface area of the cylinder is 2 pi rh. So let's go back to the question now. Okay, so let's just get these written down. So as far as the cylinder goes, the volume is pi r squared h, okay, where this is h, the height, okay, and the surface area is 2 pi rh, okay, and for this one the volume is 4/3 pi r cubed, and the surface area is 4 pi r squared. Okay, now what we're saying here is that if we look at this, we can substitute the expressions for the surface areas into this equation here, can't we? So the total surface area of the cylinder, which is 2 pi rh, but there's something else we've got to think of here, haven't we? We've also, these are solid shapes. It's a solid cylinder, okay, which means that we've also got the tops and bottoms to think about as well. So the area of each of these tops will be pi r squared. So we've actually got another 2 pi r squared to add on to this, 2 pi r squared. Okay, sorry, 2 pi r squared, there we go. So mustn't forget that. So let's have a look. So total surface area of the cylinder then is 2 pi rh plus 2 pi r squared. Yes, and we're going to divide that by the surface area of the sphere. Surface area of the sphere is 4 pi r squared. And apparently this equals 2. Now, so this is interesting. Now this can be simplified hugely because if we notice we've got pi's everywhere, and we've got r's top and bottom, and we've also got things that divide by 2 top and bottom as well. Right, now, so let's see, what are the common factors? 2 will go into everything, pi will go into everything, and r will go into everything. So I'm going to divide everything by 2 pi r. So I'm going to divide this by 2 pi r, I'm going to divide this by 2 pi r, and I'm going to divide this by 2 pi r. Okay, so let's have a look. That gives me, let's see, let's see what's going to happen. The 2 will cancel with the 2, the pi will cancel with the pi, the r will cancel with the r, and we're just left with h there. The 2 will cancel with the 2, the pi will cancel with the pi, and this r will cancel with one of these r's, so the squares will go. Squared will go there. And here we'll end up with 4 divided by 2, that will turn into 2, and the pi's will cancel, and the r's, one of these will cancel with that one there. So we end up with just 2r on the bottom. So we've got, just to simplify that and make it look prettier, we've got h left here, plus we've got r left here on this one, and we've got 2r left here equals 2. Now, because that's a bit messy, that's my fault. If you're not sure about that, just go through it. You could divide by, instead of dividing by 2 pi r all at once, just do it one at a time. So divide by 2, get those sorted out, then divide by pi, and finally divide by r. Do it in stages, okay? I've done it all in one here, just to save time on the video. But you know, you just go through it yourself and just double check that what I've got here is right. Okay, so we've got h plus r equals 2. Now I'm going to get rid of this. I'm going to get rid of this 2 on the bottom. We don't like fractions in algebra, so I'm going to multiply the whole of this side of the equation by 2r, and therefore I've got to multiply this side by 2r as well, haven't I? So that will cancel with that, and I'll be left with h plus r equals 4r. Now that looks really nice, because obviously we can go further with this now, and we can, if I take r away from both sides, I will end up with h equals 3r. Now we like this. This is nice and neat, isn't it? After having all this here, we've actually come up with a lovely little formula here. Now, so that was from this one. We haven't used this yet, okay? But we used this one to come up with this. Now let's have a look at the volumes then. So we've got, we're after the volume of the cylinder. Well, the volume of the cylinder is pi r squared h divided by the volume of the sphere, which is the 4/3 pi r cubed. So let's just write that down. So the volume of the cylinder is pi r squared h, and the volume of the sphere is 4/3 pi r cubed. Right. Now straight away, again, we can see that we've got things cancelling. The pi's will cancel out. Okay. If we divide both top and bottom by r squared, this will go, and this will disappear, because it'll just be r to the power of 1, or r. Okay. So we've then got that cancel, that simplifies to h over 4/3 r. Now this is a bit messy. I'm just going to write it like this. Okay, and then I'm going to change this to a. I'm going to put this as an over 1 to make it look like a fraction. So we can treat this as the way that we divide fractions. Okay, and we do that by changing this to a times, and then we flip this one over, don't we? So this will be h over 1 multiplied by 4r over 3. Okay, so that's going to be, let's see, how will I write that? 4hr over 3. Okay, now this is interesting because, look, we've got this here, this says that h is the same as 3r. So why can't we substitute this in here instead of h? No, something's gone wrong. Wait a minute. Yeah, I did something wrong. Did you spot it? I hope you spotted it. What didn't I do? Tut, tut, tut. This should be 3 over 4r, shouldn't it? Well done. I'm glad you told me about you. Yeah, thank you. Okay, let's rewrite this again then. So that's 3h over 4r, isn't it? Okay, 3 times h, 3h over 4. That's better. Now I'm going to substitute this into here, and I will end up with 3 times 3r. Well, 3 times 3r is 9r all over 4r. And these will cancel out, and we'll be left with 9/4. Now that's a top-heavy fraction, so I'm just going to convert that into a mixed number, 2 1/4, or 2.25. So there we go. So if you like, the scale factor of the volumes, because this is what this is going to give us, isn't it? Just like this is the scale factor for the area, the scale factor of the volume will be 2.25. Well done. Okay, that's the end of the paper. So I hope you've gained something from watching all that. I'm not going to be doing another one, I'm afraid. But if you want any help at any time, you know where I am.